This is our last chapter, changes around us. Already we started. So let's see once again the review. We revise the previous topic and then we go to the today's topic, right?
Yes, sir.
So change means what? Alteration of a substance, okay, from its original shape or size is called as. Can you see the total screen?
Yes, sir.
Now, okay. So is called as the change. So these changes we can see so many different types of changes over there. An example we discussed in the previous class only.
Yes, sir.
Okay, milk turns, sow, seed germinate, the weather changes, and fruits ripen. So changes can be different types of there. Desirable, undesirable means which are wanted to us, which are unwanted.
Sir, we discussed slow and fast changes.
Slow and fast changes. I think temporary, permanent also discussed. Reversible and irreversible also discussed, I think.
Yes, sir.
So these all we discussed: desirable and undesirable, slow and fast changes, temporary and permanent, reversible and irreversible changes. Today, let us discuss about the physical and chemical changes. This is a very important. In the chemistry, totally we are going to discuss mainly about the physical change and the chemical change. And in the upcoming class also we will be studying mostly about the chemical changes, right? So let us see what is maybe the physical change. Physical change means what? If the changes occurs in their physical properties, such as shape, size, etc., then that is called a physical change. Okay? So means what? If there is a change in the size. For example, if we have one sponge, you know the sponge, and if you press it, so then what happens? It get compressed and it will changes into small shape. Now, if you release the force, again it comes to its original state. So there is a change in the size, shape, etc. State also. Okay, state that is called as a physical change. So you have to remember that during the physical change, no change will take place in its composition. Composition is what it is made up of. That is called a composition. So there is no change in what it's made up of. Remember, very important point here. Okay. So that is no change in the composition. If there is no change in the composition, then no new substance is formed. So here we do not get any new substance. And it is reversible. Okay. So remember these four things. What are the four things? First one, only change in the physical properties like shape, size, and state, etc. Okay, that is the first thing you have to remember. Second thing what you have to remember is that there will be no change in the composition. Means what? How it is made up of. In that there will be no change. Third one, if there is no change in the composition, then no new substance is formed. So there is no new substances formed, the same things remain same. Okay, and generally they are reversible. Reversible means what? Once they change into other shape, again we can get into original shape. So these are the properties of a physical change. Is this clear to you?
Yes, sir.
So here you see the changes can be classified into two more types. One are called physical and chemical changes. Physical change is that when the substance undergo physical change. Physical change means what you have to remember? What you have to remember? Physical change means what? Shape. Okay? Size and state. Okay? So such type of changes if it undergoes, then that is called a physical change. It does not give rise to a different kind of substance. So it's not giving any new substance. So no new substance is formed here. Okay? And mostly it is a reversible change. Means what? Once we change into something, so again we can get into original state after a certain of time. Now you see here, can you see a crushing of can? Okay, what is the crushing of can? So see, for example, I have this water bottle. Okay. After completing the water bottle, after drinking this water bottle, if I crush it, so does it remain the
Yes,
same
sir.
shape?
Physical change, sir.
So that is a physical
Return
change.
back to normal effect.
Right. So that is crushing of can. Melting of an ice cube. So ice cube if I keep outside, okay, under room temperature, it will melt. Again if I freeze it, again it comes to ice. Yes or no? So here there is a change in the shape. Where is the change in the shape? In the crushed can. Okay. Now in the second one, where is the change? Change in the state. Yes or no? Change in the state. Because, yes, this is a solid state actually. Ice is a solid. But on melting, what it becomes? It becomes liquid. Water it becomes. So, solid state to liquid state. So, here change in the state. Here change in the shape. Right? Now, next boiling water. Here actually the water is in liquid state. Okay. Now on boiling water pans it will be converted into vapor. Yes or no? It is converting into vapor. So from liquid state to it's changing into a gaseous state. So here also there is a change in the state. Mixing sand with water. See, for example, we have a water. One glass of water. Now we have a sand. Sand means no isuka. Okay. And we drop the sand in the water and stir it. Okay, mix it. Now after some time, you filter it. You filter it. You know the filtration? You on filtering water means only water gets separated and the sand gets separated. Yes or no? So both can be separated. So this is a physical change, right? Now breaking of glass. Breaking of glass means what? Is it a physical change or chemical change?
Sir, physical change, sir.
Physical change only. Okay. So many people what they ask is, sir, if I break you said that the physical changes or reversible reactions, reversible changes,
Yes,
and
sir,
if
I
once
just want to say.
if it have a break, if you break it, can again you join it? No. Okay. In that sense, it is not a reversible change. But the thing is that here our main concept is that it is not giving any new substance, no change in composition. Means what? For example, you see this is a pen. Okay, so I'm breaking this one into two pieces. Now here after breaking into two pieces also, for example, this total pen is made up of some material, plastic. You think if I'm breaking them into pieces. Now each piece is made up of plastic only, no? Is there any change in the composition? No. Even if you break the glass also, glass will be converted into small pieces, but still glass is glass only. Yes or no? So there is no change in its composition, only physically it was broken. Physically it was broken, but no new substance is forming here. Okay, even if you take one big mirror and break it, so it becomes small piece. Now in the small piece also, it will reflect the light. So it will have the same features like as it has a big one. Okay, so hence it is a physical change only. Remember that if any new substance is forming, then only it is called a chemical change. Is this clear to you?
Yes, sir.
Right. So even after breaking also the glass will remain as a glass only. Okay, so that's what it comes under physical change only. Then come to the dissolving sugar in water. So for example, in the water, if you add the sugar and stir it, here it is different here. Here in the water we have taken the sand and filtration we got separated the sand and water. So this is a physical change. But here we are taking the water and sugar and stirring it, sugar is completely dissolving. Does it comes under physical change or not? Or chemical change? Yes.
Physical change.
Physical change. How can you separate the sugar and water again if you want?
We can't separate, sir.
Why?
Yes, sir, we can separate, sir.
You can separate. Okay. If you boil that water, so sugar syrup, then what happens? Only water will be getting evaporated and the sugar will become presented down only. Yes or no, in the vessel only. Only water will be getting evaporated. Yes or no?
Yes, sir.
So we can separate them. So this is also physical change. Shredding of paper we are tearing. Chopping of wood also we are cutting. and mixing of green and red marbles and sublimation of dry. Sublimation means what? What is mean the sublimation? Already I think we discussed somewhere in sublimation. Did you remember the sublimation?
Yes, sir.
What is the sublimation?
Sir,
The process of converting the solid directly into gaseous state without going to the liquid state. Okay. Generally, if this plastic is there, if I heat it, so what happens? First it melts and liquid, it converts into the liquid. Still, if I heat it, so that will be converted into the vapor state. So when I am heating the solid, generally, most of the solid first they turn into liquid state. Yes or no? After that, they are converting into the gaseous state. But sublimation means what? Without going into the liquid state, directly if it is converting into the gaseous state, from solid state to gaseous state, then that is called sublimation. Clear?
yes, sir.
Right. So these are the physical changes. So now in detail you see the physical change, one property. So have you taken the screenshot of the previous slide?
No, sir.
How you? Then how you take this screenshot, you take of this one.
Look, sir.
Chuka? Okay then go to the next slide. Now we are one by one points in detail it is given here now. Okay. So see a physical change means what? When a substance undergoes a physical change, its composition remains the same. Composition means what? By what it is made up of. Okay? By what it is made up of, that remains the same. For example, water. Okay, let us take water. Water, it is in liquid state. Which state? Liquid state. Okay? Now, this water, I freeze here. What I will do? Freeze means what I'm putting in the refrigerator. So then it becomes what? It becomes ice. It becomes ice. So ice is what? It is converted into solid state. Yes or no? Now, this water, now this is what I'm doing. I'm boiling, means what I'm heating. On heating, what happens? It will convert into the water vapor. Water vapor. Okay? Is this clear to you?
Yes, sir.
Now, composition means what you see now here. So, water. What is the formula of water?
Sir, formula for this, sir. Sir,
H2O means what? Water is made up of 2 hydrogens and 1 oxygen. So this is composition. This is called composition. Composition of water is H2O means what? 2 hydrogens, 1 oxygen will join to form the water. Now this water I am freezing. So your liquid state to it is converting into solid state. Now if I ask you now, what is the composition of ice? What is the formula of ice? Then what you say? Chaitanya?
Sir.
What is the formula of ice?
Sir, I don't know, sir.
Array, H2O only. Ice is nothing but a water only, no?
Yes, sir.
Then, so H2O only. Water for ice formula is nothing but a H2O. So water is H2O liquid state, you are freezing, so it becoming solid. Now also the formula is H2O only. So no new substance is formed, no change in the composition. Okay. Now I am taking the water H2O, I am boiling, and it is converting into water vapor. If I ask you now what is the formula of water vapor, then what is the formula of water vapor? What is the formula?
H2O.
H2O. So very good. So the formula of water vapor also H2O. So in the solid state also formula H2O means made up of 2 hydrogens, 1 oxygen. In solid state also H2O, 2 hydrogens, 1 oxygen. And vapor state also H2O, 2 hydrogens, 1 oxygen. So the meaning is what? Whatever the changing the states, physical changes it's undergoing. But still composition means how it is made up of, that remains the same. So here that is the thing. So its composition remains the same. Is this clear to you?
Yes, sir.
Right, very good. Then physical change is a temporary change. Already we discussed a temporary. Temporary means what? For certain time of, okay? Only for certain period of time, it will be there like that. Again, after those conditions, if the conditions changes, it comes to its original state. So if I'm taking the water, I'm freezing it, so it becomes ice. But as long as I put in the refrigerator or I'm freezing, then only it will be in the form of ice. If once I take from the refrigerator, so that becomes liquid. Means what? Again, it's coming to its original state. Means what? It's not permanent. It is temporary. For a particular period of time only, it will be changes. Okay. Now, physical change affect only physical properties. This is important. So, see where you can find the changes: shape, size, and state also. Okay, and state. Only in this one only you can find the change. Physical changes will take place where? In the shape, in the size, and in the state. Okay. And in a physical change, no new substance is formed. This is very important. No new substance. So if you are taking the water only, you are taking the ice, water only, you are vapor, water only. So here no new substance is forming. Water is water only. Whatever it may be the state, the composition remains same. So new substance is not forming. So this is called physical state. Next, physical change easily reversible. Original substance can be again we can get original substance very easily recovered. And some examples for physical change is freezing of water, melting of wax, boiling of water, etc. Is this clear to you?
Yes, sir.
Right. Now take the screenshot of this one also.
Look, sir.
Okay. So now is this clear? Physical change, everything?
Yes, sir. Clear, sir.
Right. Now come to the chemical change. Now chemical change is quite opposite to the physical change. Quite opposite to the physical change. So physical change means what? There was only changes in the physical properties, only physical properties like size, shape, state, etc. But in the chemical change, there is a change in the composition. There is a change in the composition, how it is made up of. From that composition, there will be a change. Okay. If there is a change in composition, the meaning is what? New substance will form. What will form there?
New substance.
New substance. In the physical change, what we have seen? No new substance will form. But here, it forms a new substance. New substance will form here. Okay. And here, most of the chemical changes are irreversible reactions. Irreversible changes. Irreversible means what? Which cannot be recovered back. Okay, again we cannot get, maybe original shape we may not get. So such type of changes are called chemical changes. Okay, so here the most important points what you have to remember is, first one, there will be a change in composition. Change in composition. Second one, if the change in the composition, new substances will form. New substances will form. And third one, mostly they are irreversible. Means what? We cannot convert them. Mostly they are irreversible. Means what? We cannot reverse it back. Okay. And mostly the reactions are permanent also. Once if they change, forever it will be like that only. Okay. So that is called permanent. So these are some of the properties of the chemical change. So you can see here, chemical change means what? A chemical change occurs when two or more chemical substances react to form a new product that have entirely different set of properties. So here what's happening here? Here most of the chemical changes, what happens is, when two or more substances are combining, when two or more substances are reacting with each other, then what happens? Some new substance will form here. Okay, a new substance will form. For example, you see, generally, we have a so rice is there. Rice, you know the rice, and mom will cook the rice. Okay, so we should take the raw rice. We can't eat the raw rice. Can we eat raw rice? We can't eat raw rice. So what we do? Our mom will wash that rice and she'll pour the water and cook. So on cooking, what happens? This rice now it becomes food. Okay, to eat. It's ready. So now generally we eat that food. Now once the raw rice is cooked into the rice cooked food, does it again changes into raw rice?
No, sir.
No. So that is like example for okay chemical change. So here two or more okay substance are reacting to form a new product. When two substances means what? For example, here raw rice and water, both are combining. Okay, both are reacting to form the cooked rice like this. Okay, and that entirely different from the set of properties. A chemical change is mostly irreversible. See here, mostly irreversible means what? Again, we cannot get them back. Like once if the rice is cooked, we cannot make it into again raw rice. Okay. And here cooking food example, ripening of fruit, lighting of matchsticks, and aging of leaves, digestion of food. Okay. So all these things once they happen, can we get it back again?
No, sir.
No, we can't get it back. Once if it is cooked. Now repairing of fruit means what? కాయ పండు అవుతుంది బట్ పండు అయిన తర్వాత మళ్ళీ మనం కాయగా చేస్తామా? No, we cannot make it. Lighting of matchstick. So once if you light up a matchstick, that will burn. Can you get it back again? No. Aging of leaves. Even our age also. Okay. Once now you are a boy, means your children, like a small boy, you are okay enjoying a lot. Once if you become elder, now you want to go to that backstage. Can you go there?
No, sir.
No. When I listen Chaitanya's words, I feel that I also be like I want to become like a Chaitanya now. Okay, so like that. But is it possible to me to become like Chaitanya like 7 years or so, 12 years old or a 7th class student? It's not possible. Okay, right. Now digestion of food. Once if we eat the food, that will get digested. Now digested food we cannot convert it again food. So these all are the examples of chemical change. Some examples you see here. Burning of wood. Yes. If we burn the wood, can we get the wood again back? No. That becomes ash. Okay. Now rotting fruit. So fruit also once if it is rotted, we cannot get back it. Baking of cake. See, she is using atta, means flour, and the sugar and everything, whatever things she is using to bake a cake. And after once the cake is made, can we get all those things, raw things again back? No. Rusting of metals. So you know that metals will rust, and usage of battery. So all these things are examples for the chemical change. Is this clear?
Yes, sir.
Chalo, take the screenshot of this one. Right. Now let us see detail one by one actually what happens in the chemical change. So see here, when a substance undergo a chemical change, its molecular composition is changed entirely. Its molecular composition changed entirely. The meaning is what? For example, you take one coal. You know the coal, bugu?
Yes, sir.
That is mainly made up of what? Do you know? Oh,
Sir,
oh.
yes, sir. Carbon dioxide.
Yes, only carbon, not carbon dioxide, carbon. Okay. So what we are doing? We are taking the coal and we are burning the coal. Okay. So here burning means what? Actually, burning means what?
Sir,
Hmm.
burning, sir.
But
When I
okay.
say one,
In normally, okay, in normal, yes, in normal language we can say that burning means okay, it's burning. Okay, I can understand. But in chemistry, burning means what? It is reacting with oxygen.
Okay, sir.
Because you know that to burn it requires the oxygen. You might have studied in the lower class somewhere. For example, you take one candle and light it, so it will it will light. Now you take one tumbler and hold the tumbler, put it ulta on this one. So after some time, what happens is this will be put off. Yes or no? Did you study this one? When you put the tumbler over the burning candle, so it will put off.
Yes, sir.
Why? Because it requires the oxygen.
Yes, sir.
It requires the oxygen. So in presence of oxygen, mostly the substances will burn in presence of oxygen. So here coal is burning to give the flame, means what? Energy. Flame means what? Like a heat. Okay, you can write heat. So it's giving the heat, okay, and of course light also. So here in present here normally in English we can say that coal is burning and giving the heat. By using that heat we are cooking something and we are doing something. But in chemistry what's happening is coal means actually coal mainly consists of carbon. What it consists of? Carbon. And it is burning means what? It is reacting. Plus means what? Reacting. React with the oxygen. Reacting with the oxygen. The atmosphere oxygen is there. And to burn anything it requires the oxygen. So it reacting with oxygen and forming the carbon dioxide. And forming what? Carbon dioxide. So here we think that coal is burning means what? Only coal is burning. Only alone one substance is burning. No, actually two substances. Oxygen also there, but we can't see the oxygen. Okay, so the meaning is what here? Carbon and oxygen, two substances are joining, combining, and forming a new substance called carbon dioxide. So that's the meaning of this one. When a substance undergoes a chemical change, its molecular composition changes entirely. I am taking the carbon here and individually oxygen is there, but these both are reacting and forming the new substance called carbon dioxide. Okay, so like this new substance with the new molecular formula we are getting here. A chemical change is a permanent change. You know that it forms a carbon dioxide. Again, can you change that carbon dioxide into carbon again? Is it possible to change the one carbon? No. So we cannot change. Okay. So chemical change both the physical and chemical properties of substance, including the composition. So total it will changes. Chemical properties as well as physical properties also will change. Why? Because carbon is a solid, but carbon dioxide is gas. So physical properties also will changing and chemical properties also changing. A chemical change is always accompanied by one or more new substances. So this is most important. So always we can get one or more new substance. We are getting the new substance, that is carbon dioxide. And chemical changes are irreversible. Irreversible means what? Once if it is turned into carbon dioxide, we cannot change them into again carbon. Yes? Now, some other examples we can see here. A few examples for chemical change: digestion of food, burning of coal, rusting, etc. So these are the individually, okay, points of a chemical change. Is this clear to you?
Yes, sir.
Chalo, copy this one, means or take the screenshot.
I took, sir.
Very good boy. Chalo, this is most important now. So now Chaitanya, so I'll give 2 minutes time to you. Read this and this one by one differences you have to explain to me, right? So first you read for 2 minutes. 2 minutes you read for 2 minutes and then you explain to me. Chalo, is this clear now? Did you understand the concept?
Yes, sir.
Now you say physical.
First point is in a physical change, only the physical properties such as colors, physical state, and etc. change. Sir.
Ah.
No chemical properties composition is changed, sir. But in chemical change, not only the physical properties, but chemical properties such as chemical composition and etc. change, sir.
Yes, okay.
In a physical change, a new substance is not formed, but in a chemical change, completely different and new substance is formed.
Very good.
Sir, in the third one, very little or no energy is absorbed or released, sir, in a physical change. But in a
Yes.
chemical change, always a certain amount of heat is absorbed or released.
So just I told you know, so heat is now means most of the in the physical properties, means energy will be utilized, but very minimal amount of energy will be absorbed or but here what happens, see, I said, you know, if you burn the coal, so we can get a lot of heat. Yes or no? So the energy transformation will be taking place. So energy will be absorbed or released in the chemical change. Okay, next point.
Sir, physical change is a temporary change. So we can change it back to its original state after the change takes place to a substance.
Very
But
good.
in chemical change, it is not. It is permanent. So we can't change it back.
Very good.
Then in the fifth point, in a physical change, the original form of the substance can be recognized.
Regained. Regained means what? We can get back. For example, I said, you know,
Get that back. But in the chemical change, the substance cannot be obtained easily.
very good. Last and final point.
Sir, I can see only up to
Acha. Last point is a physical change is reversible and a chemical change is irreversible. Okay? So that is reversible and this is irreversible. Now can you give one example for both?
Sir, physical change is the conversion of water to water vapor and ice and
Very good.
that's it. For chemical change means burning of wood or paper or substance.
Good boy, good boy. So take the screenshot of this one also.
I do, sir.
Very good. So now is it clear to you physical change and chemical change?
Yes, sir.
Okay. Now here some figure pictures are there. In this you have to identify which is a physical change and which is a chemical change. Okay. So first one is combustion. Combustion means what? Burning of any substance in presence of oxygen is called a combustion. Now whether the combustion is a physical change or chemical change?
Sir, it is chemical change.
It's a chemical change. Very good. Next, it's a chemical change. Okay. Next, just 1 minute.
Rotting is also a chemical change.
Yeah, just 1 minute.
Okay.
Yeah, Chaitanya. So second one, rotting is comes under which what?
Sir, chemical change.
Chemical change. Why?
Well, because it can't be reversed, sir. The chemical properties of the food are changed.
Very good. Melting of
Sir,
ice.
melting is a physical change.
It's a physical change. Very good. Now shredding. Shredding is what, like
Sir,
cutting.
shredding is also a physical change, sir.
Physical
Because
change.
the substance is just, the paper is just divided into smaller parts.
But if the composition is not changing. Very good. Rusting.
Sir, rusting is a chemical change.
Chemical change. Very good. This is a chemical change. Okay. Next, digestion.
The digestion is a chemical change.
Digestion is also a chemical change. Very good. Next, boiling.
Sir,
Boiling.
sir, boiling is physical change.
Very good. Physical change. Next, cutting, chopping. Chopping means what? Cutting of wood.
Yes, sir. Sir, physical change.
Physical change. Very good, Chaitanya. So, very good. So, you clearly understood the topic. Okay. So, very good. Well done. So, today with this we'll stop. And tomorrow, in the next class, I'm going to discuss about some chemical reaction. Okay. So, means chemical reaction, just chemical reactions I'll explain you. And with the small chemical reactions. So with that we'll stop. So we need one class or hardly two classes. With that we complete this topic. Okay. So today what you do is you means actually I think till here only it is there in your book. But one additional topic I would like to explain you. So today what you do is you read the textbook and try to answer. Easy, reversible. These all topics, sir. So try to answer the questions because there will be so many examples might have given. Here and right now not given that many examples, but concept I explained you. So that's what you do. Once go through the textbook, what is the material is there? Through that material, once go through that and read the examples and try to answer the questions. Okay. In the next class, one more small topic will be there. With that, I'll complete. And by next Monday, we discuss the questions also. Okay, your worksheets also. If you have any doubt. Okay.
Okay, sir.
Okay. Okay, then we stop with this. Okay, then bye. Good evening.